Hi, I'm an old guy and I do maths. And today we're looking at what we do when we're confronted with this. Now, the instruction is draw y equals the absolute value of x plus 1. Now, on my Cartesian plane, I have drawn x plus 1. This point here is 1, and this point here, which I'll draw an arrow to, is negative 1, 0. Now, if we were instructed to draw x plus 1, this is what it would look like. The y-intercept is 1. The x-intercept we find by making x plus 1 equals 0 and solving for x, which gives us negative 1. Now, what does the absolute value of the function look like? Well, it looks like this. Just draw this in here, and then we can talk about why it looks like it does. So, there are a couple of ways of talking about this. First of all, we could say that this part of the function is a reflection of this in the x-axis, which is very true. The important point to note is that if this value down here, so that is negative 2, negative 1, so the y value here is negative 1, then the x value here doesn't change because we're looking for the value of y in terms of this. But the y value, instead of being negative 1, becomes 1 because the absolute value of negative 1 equals 1. So this point here is negative 2, 1, and so forth and so on. The y values can be worked out using this. So negative 3 plus 1 is negative 2. And then we look for the absolute value of negative 2, which is 2. Now, in a previous video, I've explained what an absolute value is, but I'm going to go over it once more. It is the distance of the particular value that you're looking for from 0. So here at this point, negative 2, 0, y equals 0. Down here, it equals negative 1. The distance between those 2 points is 1 unit, whatever that unit might be. We measure in terms of distance. The basic rule is that the absolute value of negative 1 is its distance from 0. Why then do we say, well, why do we say that is a positive distance? The short and rather cheeky answer is what my physics teacher used to say: show me negative 3 meters and I'll show you pigs that fly. Take out your measuring tape, take out your ruler, go to the left of 0, and you'll see that there's nothing. What we're looking at is we're looking at the size of something. And size is always measured in a positive way. Let me give you another example which I've used elsewhere. If I draw a circle and I put it on a Cartesian plane such as this, and this thing has a radius of let's say 3. The fact that I measure the radius out here does not mean that even though it's possibly in a negative quadrant, it's not negative 3. It's the distance from here to the edge of the circle, and it's 3. Same is true for here. Same is true for here. Same is true all the way around the circle. It is the value of the distance from 0 to whatever point there is out here. And that's the sort of thinking that's involved in this. So, the short way of contemplating this is to say, It is this function until the value of y is 0. And at that point, beyond that point, all the values that this generates are also positive. So that's one way of thinking about it. But the main point, I suppose, of today's video is just to show you what it looks like and try and explain why. So thank you very much for watching. I hope you found that useful. If you did, please like and subscribe, and I'll see you next time. Bye.